Good morning everyone. Today we're here to talk about what's new in Uniface 10. Something you will notice is we only refer to it as Uniface 10 these days. As you know, there's been a 10.1, a 10.2 and a 10.3, but for us the version or the minor version is no longer that relevant because we are now very agile in the labs. We have a release every 2 weeks with the patches, and what I mean by that is traditionally you would have seen that our patches were just fixing bugs, but now our paradigm is as soon as we have usable, tested, complete functionality, we deliver it. And with our sprints, we aim to have new functionality ready every 2 weeks. So when you look at the patch information, this is all published on uniface.info. For example, here we can see that, let's take patch 5 for example, we released TLS functionality, load definitions, replace functionality. If I come up to maybe patch 8, we improved the handling of IDE state when dealing with worksheets, which we'll learn about later on. All of this information is published on uniface.info, and yeah, I say every 2 weeks you will see that we get new functionality. Now, for the purposes of this course, we've said in the prerequisites to just install patch 5. The reason for that is because the course was built against patch 5, which was, well, 5 patches ago, so 10 weeks ago, and functionality has changed. For example, the global procs editor has changed from the old hybrid style to the new version 10 paradigm. When you install patch, I think 10, you will see that change, but in order for you to be able to get through the exercises and complete them as described, then patch 5 is the patch to have. If you have gone and installed one of the newer patches, it's no problem. You'll just notice that some things have changed location, or there might be extra functionality which isn't accounted for in the training material. What you will, however, see though is what you learn in today's training material is consistent with any new functionality we add, in that the way you learn to work with the IDE today will be how you work with it for any new functionality or any changes in the UI. The main purpose of this course is not for me to teach you about Uniface and the paradigm of Uniface, but more about what's new in the Uniface 10 IDE. So what the tool is, what some of the terminology changes have been, and how to interact with the tool. I'm not going to be teaching you best practices or how to write prop script or how to architect your application. I mean, a number of you, naturally with years of Uniface experience, know that already. What I want to teach you is how to use Uniface 10's IDE with the knowledge you already have. So we're going to cover a few things today. Some of the key points. We'll look at what's changed about the Uniface repository and what you need to consider there. We'll then look at some of the terminology changes and things that have been introduced, such as the concept of development objects and main development objects, projects, templates, palettes, and then we'll go through the IDE itself and look at some of the extensions such as worksheets and menus, and I'll briefly touch on TLS. These are some of the major themes of the new IDE. For the first number of topics on here, I will be going through a number of slides, then we'll do some exercises, and then after that we'll go into more detail about the IDE, where you'll see that we'll maybe do 1 or 2 slides and then we'll do another exercise. So this is going to be very hands-on. Any questions, just ask. Because there are a number of us on the call, I would ask that you post your messages in the chat window. I will check that every so often and I will try to address your questions. We also have a number of other Uniface personnel on the course and another number of people who've played with Uniface 10 a lot already, and they will naturally also help and answer the questions, so it'll be a collaborative effort. So jumping straight in, Uniface 10 free repository. What you need to consider here is there are a number of things that have changed. Naturally, we have changed the IDE significantly in the way it works, and with any application or solution, changing functionality potentially means changes to the data model. I mean, Uniface is driven from the repository. Now, something we have done is version the repository, so every table now has a version identifier, and what this is basically to do is to ensure that repositories remain compatible. So if I'm importing something, I know I'm importing it into the correct version of the repository and won't get corruption or odd behavior. If a repository is incompatible and Uniface is able to upgrade it automatically, then it will do so. Now, in terms of looking at Uniface's migration path, the compatible repositories that can be migrated are 9.6 and 9.7. Anything before that will need to go through 9.6 or 9.7 in order to be migrated to version 10. One of the good things with the migration is the lab did extensive testing across many customers, a number of you who are here today, and have done extensive testing to make sure the migrations are basically seamless. And I'd say 99.9% of the cases it has been seamless. Artifacts that were identified during the road trip have been fed back to the lab and accounted for, and what you will find is for migrating your applications from 9 to 10, it is literally an export, import and recompile. Now, clearly I'm making it sound really easy. There are some things to consider, and the main one is deprecated statements. When we went from, say, version 7 to version 8 and version 8 to version 9, we introduced a concept of deprecated statements that we said would eventually be removed from the product or become unsupported or just basically not be further developed. In the move from version 9 to version 10, you will see that a number of the deprecated statements, I'd say all but about 10 of them, have now moved from the deprecated to unsupported status. What that means is they will still work, so you can just do a straight export, import, recompile, and your application will behave as it did before. However, should something come up with one of those statements, we will say that statement is unsupported, please replace it with the supported statement. If anything still goes wrong, it will be the supported statement or supported constructs that we then work on. But I say, for a straightforward migration, you don't have to do anything, but just bear in mind that is a change you will need to consider. The other things with the repository and with the versioning, something that will no longer work is importing repository exports. For example, if you built your tooling around it, you won't be able to import those from the command line using /copy or UDE copy. What you have to do is use a standard export and import functionality from within the IDE. The reason for that is when you do a /copy to export the repository objects, effectively it's just a straight dump of the table out to a file. What that doesn't take into account is the referential integrity or structure of that data. So yeah, if it's a raw data dump, it's fine, but when it comes to the repository, it is structured. Therefore, you have to use the normal export and import from within the tool. Reason for that, when you do an export from within the tool, it's exporting to XML in a structured, nested way that respects the referential integrity. So that's just something to bear in mind. /copy will not work, and well, /import will not work in the same way as it used to. Because of the changes in the repository, 10.3 cannot just run against a previous repository. In the past, we used to see things where we would literally just update the version of the runtime, point at the old repository, and it would work. Well, no, that won't happen now. In terms of runtime behavior, the versioning doesn't affect the behavior of the runtime. So if you've got tools that are running compiled, they will still work in the same way, because at that point it's just runtime data being read and manipulated. Reasons for some of these changes, things you'll see, naturally as I've said, a lot of new functionality. The paradigms have been enhanced, changed a little bit, and new functionality has been added. Now, one of these new things that we'll talk about a bit more later is the use of typed libraries. Type libraries, not really a phrase we use much in Uniface traditionally. You hear it a lot when you talk about other languages, and we now use that phrase a bit more in Uniface. It's actually a really simple concept. If we look at Uniface 9, we had a library, and that library had a name. That library then contained lots of different types of objects, so it would have something such as your global procs, your global constants, your include procs, your messages, your help text, all of those different things all belong to the same library. Now, in the case of Uniface 10, those libraries are now typed, so a library can only contain one type of object. So we'll have a library of type global procs, we'll have a library of type include procs, and so on. It speaks for itself. Libraries are now typed and only contain one type of object. In practice, you won't find this makes a big change to things you do. However, the reason for the type libraries is, as you use version 10, you'll see we have this concept later on called main development objects, and each main development object has its own type of editor. So you can see the link there. A type of editor belongs to a type of object, so we have a type of library, and that library type will have its own editor, and you'll see where this fits in later on. One of the biggest changes you'll feel as well is that triggers are no longer separate. They don't have their own containers. So when we look at Uniface 9, we'd go into a component and each trigger had its own box as such. Everything is now in one container. We'll go into this in more detail later on. It's different to traditional Uniface, however, it's more in line with industry standards, and you'll find it's better when it comes to versioning and better in terms of just being able to navigate through the code and find things quickly and maintain the code. We've done things to repository. I've talked about versioning of the repository. I'm not talking about versioning of your objects, but we've added fields to deal with that. Display of the IDE objects. This is basically talking about supporting the new IDE. So we've had to make changes to the repository to control how things are displayed, how we talk about modeled objects and templates and snippets and all the other different things. It's changes to the product. It's meant we've needed changes in the repository. Something we've also done is a cleanup, so we've removed entities that are no longer used. This might seem strange as to how can we remove stuff, because a lot of it seems essential, but one of the big changes in version 10 is that we no longer support classic deployment. It's impossible. We deprecated it in version 9, we said it's not going to be there moving forward, and we have got rid of it. The good news is that means no more things such as DOL files and URR files, ULANA, UOBSHANA, all of those, USYSANA, those things that tended to be a bit complicated, and that's all gone. It's really easy now. We just create a URR or a resources folder and it's all simple. All of the objects just get compiled out there and it's clean. All of those old objects that supported classic deployment are gone. Something else we've done is redesigned a number of the properties of fields, whether that's the declarative properties or properties that you're changing at runtime. And this is things where the properties weren't necessarily obvious, or maybe a single property was doing too many things and there was, I'll use this word a few times, there was magic going on which you either understood or didn't understand. We've basically rationalized that to make it much clearer in terms of what properties are. In some cases, I say we've added extra properties to clarify things. Other cases, we've removed properties. Other times, we've split. There's been a number of changes. All of those have basically meant we've needed to make changes to the repository. Say, in terms of your day-to-day practice, you're not going to actually feel a change. It's more if you've written repository tools that have manipulated a repository, then that's where you're going to have to maybe tweak the tools you've written. Particularly if you've written code analysis tools. As I mentioned, we no longer have the individual triggers. It's all in containers that contain all triggers. So where you were looking at lots of different fields, you'll now look at one field. Not going to be rocket science to change, but something you need to be aware of. I'm going to go into a few terminology things now. A lot of these are things we've interacted with and used for a long time. What I'm just doing here is going over the terminology we use, just so that we're all consistent, and when you're doing the training and when you interact with people talking about Uniface, that we're all using the same language. One of the first concepts is development objects. These are your things that get compiled into your runtime objects. So whether you're talking about the components you build, the fields you're putting on those components, properties, your message text, proc script, menus, basically the things you're using to build your components. Not a big concept, not a clever concept, this is just what we're calling it. Again, as I say, I'm just saying these things so that we're making sure we're all using the same verbs and the same language so we understand what it is. So development objects, these are the things you use to build your components. The next concept is the main development objects. This is a slightly new concept in terms of us labeling it, but it is the kind of thing we have always had. Your main development objects are your root object. It's not a real object, it's abstract, it's a concept. So for example, my main development object could be an entity. I can have my modeled entity, and from that I'm then creating my real entities. So the top level object I build is an entity. Other things are different types of components. My main development object in this case could be a DSP, it could be a USP, it could be a report, it could be any of those. They're all just modeled components, and again, they're my main development objects. The other way to think about it is, what are my main editors? Each main development object will have a dedicated editor. If I looked at version 9, I'd have a form editor, I'd have library editors, I'd have different editors for the different top level objects, and below that I would then create all of my components. So as it says here, main development objects are the abstract object for which you then build your collection of development objects, whether that's the components that contain other development objects, your fields, your templates, etc., etc. That's what the term main development object is. What are my main things? By definition, being the root object, it doesn't have a parent object. Word main is the clue, it's the top level. They can't contain other main development objects. Now that's going to seem strange, because when we talk about projects, for example, you're going to instantly look at that and go, but I'm putting other projects in there, or I'm putting lots of other components into the project. What you're actually putting in is the derived object. My main development object is what I use to create, say, a project. That project is then a derived project. If I create other projects and put them in, I'm creating those from the main development object. However, what I'm then embedding is the derived objects. This might sound a little bit confusing, but just literally just give yourself a little time to think about it. When you play with it, it will all become clear. As I said, they have dedicated developers. Within the development objects themselves, they can be exported as an individual object, or they can be exported as a group and all of their children. So for example, if I'm talking about a project, I can export the whole project and its dependencies, or I can just export the top level, and likewise they can be reloaded. When I'm talking about reloaded from like the work area, this is the preparations for future version control related functionality. I touched on derived objects already previously. So modeled objects, such as the main development object or other modeled objects you create, this is the modeling that's happening in Uniface, and this is what you can use to create your other objects. Terminology we need to get used to, and there's just literally two rules that you need to fix in your minds. Modeled objects are something that can be inherited from. You can derive objects from modeled objects, and inheritance exists between those objects. So modeling means inheritance. What we'll talk about in a couple of slides' time is templates. The difference between a modeled object and a template is a template can be used to create a derived object, but effectively that derived object is just a copy. So the rules are: modeled objects are inherited and templates are copied. I mean, think of a template just like a photocopier or a rubber stamp. You do that stamp of the template, it comes out, and that's it. You can make a change to that stamp or that template, and it's not going to change the children that have already been made from it. Whereas when we talk about a modeled object, if you make changes to the parent modeled object, those changes will be inherited on the derived objects or the children. I will repeat this a lot because it is a core concept: modeled, inherited, template, copied. Now I'm saying it maybe as if it's something new, but it absolutely is not new. It's how it's always been in Uniface. It's just that we've not been consistent with the terminology, unfortunately. So sometimes we had templates which were actually inherited, and we'd have things that we maybe said were modeled which weren't actually inherited, and there was inconsistency, so it's led to confusion. In version 10, it's absolutely consistent. It might not seem like it at times, but again, as I say, step back, give yourself time to think, and then you'll see it is consistent. One of the key things you'll see in the IDE is that when you're interacting with the editors, you'll see the concept of templates and modeled objects, and there's two tabs, and that makes it very clear what you're actually using. Is this a template which is going to be copied and not pick up any changes due to inheritance, or is it a modeled object where I know if I change the parent it will be inherited? I'll show you that when we get into the tool. I'll also show you something where it first looks unclear, but then I'll explain where difference is there and why it actually is consistent. In terms of the types of modeled objects, the things you can model are entities, fields, properties, and components. Now, to give an example of an enhancement here is we've made the modeling consistent throughout and also extended it to a certain extent. Now, if I look at Uniface 9, I could to a certain extent have a modeled entity, for example my uDefaults entity, which would define what comes up by default. But that was only one. I can now model different types of entity, different roles and things with different behavior, and when I'm then creating new entities, so derived entities, I can inherit those changes. I'm now not restricted to just one model definition, and that's quite powerful. To give an example of where you would use this is, let's say for example you had your standard fields in an entity such as last modified user, last modified date, last modified time. That I can now model very easily and just reuse. There's going to be cases where I don't need that, so I'd want a different model, and I can just do that. I might have entities which are just technical things with buttons, or entities which are other types of audit or other technical services, key generation or whatever. Each type, if I know it's going to be reused in different scenarios, I can now model that and basically get reuse and inheritance throughout. Same sort of thing applies to fields, properties and components. As you can see here, it says component templates in version 9. Yeah, we had what were called component templates, but those component templates, they weren't copied, they were inherited from. They were actually modeled objects because what you did to those templates would be inherited. So we've standardized that terminology and we now call those modeled components. The last line, there's no more application model. You don't have a specific model main development object anymore. The model itself, that concept is gone. You do still specify what we traditionally think of as the model name as part of an entity. However, the better way of thinking about that is a namespace. If we use the word model when talking about an entity name, it does start to get confusing because we fall into a trap we fell into with version 6 onwards, where we went from the concept of conceptual schema in version 5 to the data model or the Uniface model in version 6 onwards. The unfortunate side effect of that change of terminology is it dragged us into only thinking about the Uniface data model as the model-driven development part of Uniface. And I say dragged us all, I'm talking just very general terms there. But we noticed that there was a change in the way applications were being architected and constructed, and a lot of the power of modeling was lost. By us changing the positioning and what we call the model and what we call the modeled objects, we are now making sure we really focus on the concepts of model-driven development and modeling things at a high level and maximizing that inheritance and reuse throughout applications. A new concept in Uniface is projects. These are main development objects, and this is something you will have to use, and it's going to be one of the first things you do in your first exercise. Projects are a collection of your development objects. So you'll create a project, and then to create your development objects, you basically drag and drop those into your project. I want to build a form, I open my project, I drag the modeled form into my project, and that creates my new form. I don't have to say file, new form or anything like that. I just drag the object and rename it. You create new objects, you can add to existing objects, you can compile at project level, you can export at a project level. Now, in terms of the usage of projects, we look at them as being sort of a working set. I'm just working on a particular area, I can pull in the set of components. Components can exist in multiple projects, they don't have to just be in one. So I can bring in my working set, you can almost think of it like super shortcuts, and everything I need to work on is in that project. I can work on it, when I've finished, I can just delete that project, or I can remove the objects from the project, but basically it is just my working area. How you choose to use projects and how you choose to organize is completely flexible. I mean, one of the things I do is I have a UI project, I have a database access project, I have a business logic project, but then I also have a working set project, a utilities project, a worksheet project. I have just different ways of organizing things. In terms of the components themselves, when you create objects, you're actually creating them in the repository and then just organizing them by projects. So it's a two-step thing. When I drag a component into a project, it creates the object in the main repository below the projects, and then it creates a reference in the project to that component. That's an important thing to remember, because when I'm in the project and I then just delete the component, I'm not actually deleting the component itself, I'm just deleting the reference to the component in the project. If I want to actually delete the component, then I have to go to the action menu of the component itself and say delete the object. So say the project is just a way of collecting and organizing your workspaces. The text at the bottom here says you should add orphaned repository objects to another project or delete them. That's slightly misleading text because it makes it sound like orphaned repository objects are a problem. Well, the way to actually read that is orphaned repository objects, these are just things that are not being worked on at the moment. When you are ready to work on them, you just add them to a project and work on them, and that's all it means. You can actually open them directly outside of a project, but at the end of the day you're going to be working on a set of things, so it's best to pull it into a project so that you know what you're working on and you have immediate visibility. Delete them, you can delete them, but that's just normal development. If there's something you no longer need, then you can physically delete the real component, but there's no requirement to say just because you're not working on something and it's not in an active project you have to delete it. Just don't take this statement, the last line, too literally, because it's slightly misleading the way it's written. Another new concept are templates and palettes. So I already mentioned modeled objects. Modeled objects, as I said, are the things that are inherited from. The alternative to that is templates, and templates are things that are copied. Again, they are development objects, but you take it, you make a copy, and it doesn't have inheritance. So for example, it could be that I just have a template for a list form which has very little functionality, just has an entity painted. I could take that and it's just copied and it doesn't inherit new functionality because it doesn't need to. Or it could be that I'm just having a template for a piece of code that I pull across. Again, it doesn't need to inherit, it's just a one-time copy. Or an even simpler example, a dummy entity, for example. If I'm painting a dummy entity on a form, it's just there for dummy purposes, for a dummy reason, doesn't necessarily have business logic or anything that would be reused across other components. So I would use a template for a dummy entity, paint that, and that's it. It's just a one-time copy and there's no inheritance. So that's what a template is. It's a straightforward concept. Again, as I say, the two rules: modeled objects, there's inheritance, and templates, there's no inheritance. At the end of the day, we're just copying development objects and we're just making that choice. Is it going to be linked back to the original or isn't it? And that's the only difference between a template and a modeled object, inheritance or not. A palette is a main development object that you don't see by default as something you can maintain. However, as you can see at the bottom of the screen, there is a assignment file setting called allow browse templates that allows you to maintain the palette. And what the palette is a collection of templates. So what I mean by that is, if I go back to Uniface 9, you can think of the toolbox or tool palette as your palette. So I had, when I'm painting a form, I had that toolbox which popped up and it allowed me to pick which widgets I'm going to use. And that was context sensitive. If I went to a service, I wouldn't necessarily have the same widgets available. If I went to a report, I wouldn't necessarily have the same things available. Palettes are effectively the same thing. It's for my main development object I'm working on, what are the tools that are available to me? So as an artist, I'm doing an oil painting, here's my palette of oil paints, or I'm doing some pastel work, here's my set of pastels, or I'm a young child, here's my crayons and felt tips. You just have different palettes and different sets of tools. Uniface comes with a set of default palettes, and you could edit those if you chose to, but realistically I'd suggest if you do want to change the palettes that you copy them and then alter them, or just create new palettes from scratch. It's quite easy to do them. All you do is when you're creating the objects, you can pick and say, is this a normal object, is it a template, or is it a palette? And you'll see a new property called purpose. This is something you're doing one of the exercises, so again it will become more clear. As I say, if you want to be able to view, edit and create the templates, we have to set this logical allow browse templates. You don't need to remember it, because if you just scroll through the standard assignment file, you'll see it in there and it has got a comment to say what it does. You wouldn't necessarily leave this on all the time, because what you'd be using the palettes for is to define the standards for your application. For example, these are the development objects that are available. These are the templates that I've created that enforce the standards of my application and my organization. So someone, an architect or whoever, would take care of that, would publish it for the whole team. You can change which palettes show by default in the assignment file, and then you'd lock it down by turning off allow browse templates. So the main team of developers would just have the customized environment targeted for the type of development you're doing in your organization, in line with your standards, guidelines and look and feel, etc., etc. Potentially feels like a big new concept. I mean, I'm throwing lots of new words and things at you, but it really is quite straightforward. The palette is just my toolbox of things, and it's context sensitive, and I can define multiple palettes now. Development runtime, I can switch dynamically between palettes, pick which ones I want, and also I can hard code the default palettes that I want displayed in the assignment file. So palettes are my toolbox, templates are my objects or my templates that are copied, and I said modeled objects are the things that have inheritance when I create something from them. Libraries, last slide before we do our first exercise. Libraries are effectively what they were before. The only difference now is that they are typed, so they only contain one type of objects. These are the containers for our global objects. So again, we talk about things like the help text, the message text, menus, include procs, global procs. It's what we knew of as being libraries, but the difference is they're typed. Now, an initial thought might be this could cause problems, because I had this uniquely named library with lots of different types in. Difference now is we can have different type libraries with the same name, so that will be taken care of for you during the migration if you're taking existing code in, and you will see that you have different type libraries with the same name. And then the other impact with that is if you're using $variation, then it will scan across all of the libraries with the same name as set in $variation. So from a runtime behavior point of view, it's identical. From a development point of view, you have main editors for each type of library. All of those different concepts are brought together in what is the new Uniface IDE. For anyone who hasn't seen it already, it looks very different. We have strived to make it an environment that is more productive, is more intuitive. I would say intuitive, not necessarily the right word, because intuitive makes it sound like it has to be clever and you have to be smart about it. But really, I'd say what we've strived for is to make it just more obvious, so that when you are in there, you know where to go. It's just You don't have to remember like massive form stacks of, oh, I have to go to properties, more properties, click the triple dot, and then I can set a property, and oh, I have to go to the manual to look at what that property was actually set to. No, we're trying to make things much more obvious so that you know what's going on at all times and you can easily navigate to what you need to, and ideally have everything you need presented to you on the screen already when working on an object, so that you don't have to start drilling down. Go back 20 years when PCs weren't very powerful, drilling down made sense because you didn't have a lot of power on a PC and a lot of real estate on a screen to display lots of things at the same time. But realistically these days, machines are a lot more powerful, we tend to have bigger screens, and so we can fit more on the real estate we have, and the PCs can contain more in memory, so have more going on, and so we're utilizing that power. We have the tabbed interface. You no longer have to jump between different IDEs when working on two components. Now you just switch tabs. So the idea is just to take the original paradigms of Uniface, standardize the terminology, enhance it, and make it more consistent in how you interact with Uniface, and also more informative about what's really going on. For example, when we talk about inheritance and overlay inheritance and overriding and all of those things, most of us, we've got 10 plus years of experience, we've got used to the behavior, we understand to a certain extent how it works. The good thing with version 10 is I don't need to worry about that anymore because it is consistent in its behavior throughout, but it is also very informative about its behavior, so you always know exactly what it's doing, and while you're working with it you know what it's going to do. And even if you don't or are not sure, by the time you've hit compile you'll then know exactly what's happened, and there'll be no doubt where things are coming from or how things interact, and navigating to those things becomes very simple as well, and we'll see that as we go along. So there's different elements to the IDE. So as far as possible, everything is now presented in one view without you having to drill down or open lots of other screens and things. That's not 100% achieved on everything. So for example, we can see we have this more editors, and that's where we would potentially jump back into one or two of the old library editors or more hybrid type screens, or potentially something like the signature editor will still be a separate pop-up. It is our goal over time to make sure that everything becomes a main development object and then has its own dedicated editor that exactly follows the Uniface 10 paradigm. As that happens, you'll see that functionality just come out as patches, and the reality is you won't have to learn anything new, because once you know how to use one of these editors and what the structure of these editors is, they're all effectively the same. So when we look at the structure of this page, so number one at the top we have the header, which has the U bar, so the Uniface sort of navigation bar, and this is where you can directly type in component names to open a component, or you can do the browse, pick from a drop down list to open what are your main development objects. Typically you'll find you're normally just opening the project and then doing all of your navigation from the main project area. As I say, if you want to go straight to a component, you can just type it in up here. You'll also see as you're navigating around, and just like a browser, you'll see the address in the U-bar changes. There's also a new API for interacting with the Uniface IDE directly, and you'll see that when you utilize that API, certain parts of that will also impact the values that are in the U-bar. So it's quite useful, especially one feature where the URLs can include line numbers. So if you're working with a colleague and you just say, can you give me some help on this, you can just IM them the URL here and it will take them straight to the line of code you're talking about. It also has the Uniface hamburger menu here, which has things such as the import, export, and just other help and other things from the top level of Uniface. Don't try to compare this too much to Uniface 9 because it is different. You might like say, my file menu used to have convert component. Don't get hung up on things like that not being there or not appearing to be there, because we've standardized how things work and what the meaning of things are. So when I talk about something like convert component, well, 6, we have the properties inspector, which gives me the properties of the object I'm working on. To convert component, it actually just becomes a case of changing a property, because here we can see behavior component type down here, 7, which is dynamic server page. If I want to convert this to a different component type, I just change from 7, or I just click and it will give me a drop down list, and I just pick the different component type. So although something may seem like it's missing or hasn't been implemented in version 10, quite often you find it is there, we just do it in a different way, but we're trying to be more consistent. Changing the property of a form rather than saying file, change component to something else is actually more intuitive. Might not feel intuitive because we've been doing it in a particular way for the last 20 years or 25 years. Once you get into this, you'll see, actually, if I don't know something, that's probably just a property of this object. Go and change it. So the next thing we have is number 2, the editors. So from a main development object, you get your editors. Each editor, it's a tabbed interface, so I can have an editor per tab. And within that editor, we then go down to the worksheets in that editor. So in this case, I've got a define structure, design layout, and a write script. These worksheets are specific to the type of object you're editing. So in this case, a DSP. So on a DSP, I have a structure. So that's the structure of my component, which entities, what's the nestings, what's the fields. I then have a design layout tab. So working from left to right, so I define my structure, I can then design my layout, so that's the UI aspect, and then write script, where I get my containers to start writing proc script. So that's what you have there. We then also have the compile. With the patch you've installed, you'll also see a compile and test next to that, because it just makes it quicker. Before, on this version, you had to click action test, but we thought, let's just make it simple. We'll add compile and test. And then actions allows you to do other things, such as export a component, for example. What's nice is with these worksheets, and you'll see towards the end of the course, is you can add your own worksheets and extend this functionality. I won't go into too much detail about that now, because we'll talk about that later on. Next, we have the resource browser, and you heard me mention a number of times, and I'm going to repeat this over and over again. Templates, which are copied, and modeled objects, which are inherited from. Here we'll see the set of templates that we can apply to the object we're working on. So in the case here, we can see like an empty non-database entity, so I can just drag and drop that to paint my non-database entity, and then data entry fields, so the different types of fields I can drag. These are all just templates, so I copy them and they're not inherited. If I click modeled, and I've got modeled objects defined, I can then drag those on, and again, those will then be inherited from. In 5, we have the main worksheet editor, and so that's where you are doing the real editing on your actual component. So in this case, this is the component structure editor. I'm saying structure editor, but that's not the Uniface structure editor, like gold key support and all of those things. Now this is just the structure of the component, so it allows me to edit that. So define structure. If I did define layout, then I'd have my layout editor, and write script, I'd have my containers on there for writing the script. 6, something I'm so happy to see in Uniface, is the properties inspector. No longer do I have to right click and say properties, or go to a menu and say properties, or drill down. Every property that's relevant to my object, whether it's inherited or something I can modify locally or only define locally, is displayed. It's context sensitive to the object that's selected, and I see everything's there. The ones that are greyed out are the things that are just inherited or that I can't change, and the ones that are darker are things that I can change. But the key thing here is every property for that object is available in this properties inspector. So again, no more drilling down, coming back out, forgetting that you did something, have to go back down. And the other thing that this supports is multi-select. We saw some of that coming in version 9 and the later versions. Here, if I select multiple objects, so the shift select or control select to select multiple objects, then the appropriate properties that are common that I can change will be available, and if I change them, again, that will get applied to everything at the same time. So again, no more drilling down and drilling up 20 times. It's just all done in one go. Finally, we have the output tab, so that's things such as messages or compiler output. Looking at the new editors, I've talked about the new editors, and we have them for the main development objects. Where you'll see the new editors coming up is when here we have browse and we pick the components. The component types or the main development object types you can pick here all have new editors, so following this new paradigm where we have the editors here, like an editor per tab with the worksheets on the editors. I say it's a drag and drop interface. Key things to note about the new editors is Uniface 10 is autosave. So based on when you stop typing or when you change focus to something else, it will autosave as you go along. It is something new to get used to. You can, in the assignment file, set a setting which controls how long it is between your last key press and the actual autosave, but it's not something you can actually disable. The layout editor and the script editor support undo and redo, so with Control Z and Control Y. That's one of those areas of functionality where we want to extend it further and further, and that's something you will see as patches come out every 2 weeks. In terms of getting the new editors, and this is something you'll do in the exercise, you create your new components by dragging, you can't see it here, but you'll drag your resource onto the project and then double click that item or rename it, double click it, and then it will open the new editor for you. What I do is just give you a quick example of that. So if I go into Uniface 10, something you can just see here straight away, which is nice about Uniface 10, is it remembers where I was. So I've been working all sorts of things, it's come straight back in, even down to the line number, and the last search I did is still highlighted. So that's really good for when you're just working, coming back the next day and carrying on from where you left off. But yeah, let's assume I was doing something from scratch. So I'd create a new project. So we can see I've got my new project there. Let me give it a name. What's new 10? And then let's say that I wanted to have a new non-modal form. So here's my template for a non-modal form. I just grab it, and that's it. Now, just make sure one thing doesn't get very confusing here is I've said templates are copied and modeled objects are inherited. So I said the templates will show me all of my templates, but then I see modeled entity, modeled component. The thing here is, don't let this confuse you. What this is a template for a modeled component. So here I've just said I'm creating a new form, but if I wanted to create my own modeled component, which would then appear as something I could inherit, I would just drag my template modeled component. So that's created a copy of a modeled component for me. I can now edit that, and when I publish it, it will then appear as one of my, well, actually I say it will, it already has appeared as one of my modeled objects. So I edit this, I can add my entities, my fields or whatever to that. If I then wanted to use that as a inheritable object, again, I go to my model tab and I drag that, and so this one, which is based on, if I go into it actually, we can just see, and you're going to do this later as well, we can see that inherits is true and it inherits from UFRM1. I mean, I've just thrown a number of things at you quite quickly there, but I just wanted to make sure that you realize that these modeled components are, it's just the name. These are the names of the templates you're copying. So this is a template for a component I want to create. This is a template for creating a modeled component. It's not saying that this is actually the modeled component. For the modeled components I can use, I go to the modeled tab. You are going to try this. Again, I'm going to repeat this a million times. You're going to hate me for saying it 500 million times, but templates are copied, modeled are inherited. Once I've got my object in the project to edit it, I just double click, and then again I've got my resources, paint a dummy entity, can paint a field. I mean, now it just starts feeling like regular development. Where I said that we have this properties window, it's great because, again, at the form level, here's all my form related properties, nice and easy. Entity, it's context sensitive. Edit box, again, there's the edit box related properties. If I paint two edit boxes and I highlight both of them, then the common properties I can change across both objects are highlighted. If I highlight an entity as well, again, common things I can do there. But as you can see, that's relatively straightforward. When you're doing things, the first thing you'll do is create a project from the menu over here. Then you go to your project, so my What's New Temp project, and then everything follows the same pattern. Pick the type of resource, whether it's modeled or templates, drag it into your project or the object you're editing, and then interact with it. In this case, I double click to open it, and then the pattern repeats. I've got my active object, I've got my resources, drag them on, interact with them. In this case, I can't drill down to another editor here because an edit box is a development object, not a main development object, so I'm just then interacting with it through its properties. And then we saw the various tabs, define frames, so I can write some script here. So I'm now into the containers, which we'll talk about a bit more later on, but this is where I write my code. Statistics, this is a worksheet that I've added, and you're going to do this in your exercises. It's not a standard Uniface, but as you can see, I've extended it, and it's a very simple form which you're going to build yourself, but it tells me stuff about the component. So I painted one entity, I've got two fields, and there's 6 lines of code in there. And there's all sorts you can do in this area, but you'll see more of that when you do the exercises. So within the new editors, I mentioned code containers, and this will be one of the biggest operational changes or usage changes you find, because you no longer have separate triggers that you can click on to maintain the code. What you do is create triggers in the containers. So for example, you can see operation exec. Operation exec was always a standard operation, but it was treated as a trigger in the UI of version 9 and previous. But here we've made it consistent and standard, and we are showing it as an operation. So that's like your main entry point. Standard Uniface, it's just specified in a slightly different way in the main script container. Your triggers are what they were before. It's just that we now have the keyword trigger and then the name of the trigger. Some trigger names have actually been renamed to basically make it a bit more intuitive as to what they're for. Something, for example, would be something like get state and set state, which were originally introduced in the early days of web development, and we sort of thought, yeah, they're just targeting state maintenance on a web component, or if we're serializing components. But we found people use them for many other things, and the reality is they are triggers that just fire before activate and after you activate, and that's different to init and cleanup. Init is fired as part of the new instance or directly after the new instance, and cleanup is fired directly before the final part of deleting an instance. So those are one-time things, whereas get state and set state happened every time an activate was called. Get state and set state weren't entirely intuitive, so we've renamed them to pre-activate and post-activate. That will be taken care of during the actual migration, so you don't have to go through and change anything yourselves. The triggers, operations all go into the same container. You'll see that containers will typically have 2, possibly 3 areas. You have declarations, and declarations is where you can do things such as your defines. So before we had defines trigger, but now it just goes into the declarations section of the script container. And component variables, they also go into declarations. So you just have a variables block in the declaration section of your container, and within that you just specify your variables. It's a lot cleaner because I don't now, when I'm editing, have to go into a separate pop-up screen, define things separately, and then come back out. No, I'm just working in this one container. I can scroll up and scroll down, but then also in terms of doing things like code analysis, I'm just looking at one container. The containers are naturally context sensitive, so if I go to an entity, for example, then we'll see a slight difference. There'll still be potentially the main script container, but for something like an entity, we'll also see things like the collection operations and the occurrence operations. So we'll see sections for those in the container. One other thing about containers feels a little bit different to version 9 is when we had inherited behavior or code in version 9 in a trigger, for example, then you would see that code in the component, you would see it in the trigger. In version 10, we only see the local variations that basically break inheritance. Let me try and reword that slightly differently. In version 9, my trigger would show me the code that came from the model, and that inheritance effectively took place at build time. So you created your component, it would inherit the code from the parent objects or the model when you created that component, so you saw the code there. To then break the inheritance, you changed that code. If you deleted the code, it would revert back and it would pull back in the original copy. In version 10, the container is effectively empty apart from default code, and it won't show you the stuff that's been inherited directly. What happens at compile time, the inheritance is resolved and we get what's called the compiled modules inspector, and we see a list of everything that's been inherited, and we see all of the code that forms part of the component. Now, it might seem like a loss when I say that you don't see the stuff straight away when you're building the component, but the compiled module inspector is much better because what you see in here is exactly what has gone into the component, and you don't need to try and think in your head, have I actually overridden here? Is this a local variation? Is there overlay inheritance going on? With templates in particular, is there magic happening where there's overlays which you couldn't see actually happening? And again, depending on is something at the top or is at the bottom, basically the magic's gone. The compile module inspector tells you how things are as they are, no question whatsoever. And the other good thing is, for the compile module inspector, when you double click an item, it will take you to the appropriate editor or the appropriate location of where that code's come from, and if you then want to maintain it, you can do it there. If you want to make a local variation, you can just copy it and paste it into the main object if you want to have a specialized version of that in your local component. It is a change to the way things work, but you will find it will make maintenance and understanding the code a lot easier, because you're then not questioning where the things come from, and also magic that used to occur is no longer there. It's pure science now.